Hi, I'm going to present the use case of an application that needs to curate data external to the blockchain. We're going to integrate a blockchain biometric and biographic solution called GoBio with a fraud prevention API from Seon. First of all, let's understand the purpose of GoBio. GoBio allows the integration of different databases of people records in a way that guarantees the data uniqueness in addition to allowing decentralized biographic and biometric queries where different entities or actors can carry out actions to recognize people. It's a solution implemented with Hyperledger Fabric permissioned blockchain technology that can be used to fight fraud. Now about Seon. Seon is a company that provides fraud prevention tools. One I would like to highlight is an email API. Given an email, the API returns a series of important information about it, such as which social networks the email is registered with and whether a data breach was involved. In addition, a score ranging from 0 to 100 is also returned, which indicates the probability that the email is fraudulent. The documentation says that a score greater than or equal to 8 is considered risky, that is, it's more likely to be fraudulent. So we can integrate the email API into GoBio by creating a transaction that returns the person's record among the different databases that is more likely to be fraudulent based on the registered email score. With this, it's possible to take actions to fight fraud, such as blocking some services for that person. This transaction needs to query data external to the blockchain, as the score information comes from the Seon API. But there may be the consensus problem. To visualize the problem, let's take a look at this example. We have a network with two orgs with the GoBio chain-code installed on their peers, where the consensus policy is the majority must endorse the outcome of a transaction. Then a client invokes the transaction that needs to query the Seon API, and both peers will execute this transaction. And suppose the org1 peer chain code queries this email, and the API returns a score of 5. In another moment, the org2 peer chain code also makes the same query, but this time the API returns a score of 7. This value is actively used to obtain a result of this transaction, so the outcome can be different. So the endorsement policy is not fulfilled since the orgs don't agree with the result. So when we have to query external data, it's not possible to guarantee that the result will be the same for all orgs. Before presenting the solution, I would like to introduce a concept called Oracle. Generally speaking, an oracle is a tool or entity that provides answers from a data. From a blockchain perspective, it would be a trustable data source, which provides the same fact given a value. Here we can already see the usefulness of implementing an oracle to provide us information from outside the blockchain. So the solution is, we need to have an oracle on the blockchain that will provide us a score given an email. The oracle is implemented as a chain code and an organization where only the oracle organization must endorse the oracle chain code transactions. Now the GoBio chain code must query the oracle. For that, the oracle chain code needs to be installed in our peers where the GoBio chain code is also installed. Before invoking a GoBio transaction, the oracle needs to be filled with the facts that these transactions will use. In this case, it's the email score that are on a person's records in each database. That is the database of org1 and also of org2. For this, it's necessary to invoke an update transaction of the Oracle with the emails that need to consume the score. Although the Oracle chaincode is installed on the peer of org1 and org2, only the result of the chaincode installed on the Oracle peer is considered due to endorsement policy. Now, with the necessary email score on the blockchain, it's possible to invoke the GoBio transaction. And this time, the GoBio will not consult the Seon API, but the Oracle. And the value will be the same for both organizations and codes. And given this, the outcome will be the same and the endorsement policy will be fulfilled. Based on the tool called CC tools developed by GoLedger, the Oracle is composed of an asset called query type, which aims to define and limit the types of external queries that can be performed with the Oracle. See that the asset has the following properties: the name of the query, and in the GoBio with CEO example, a name would be like email, and the another property is base URL, which sets the HTTP request base URL without the arguments. And finally, the arguments that can be added to that request. The Oracle is also composed of a result asset, which will store the result of a query. Now about the transactions that the Oracle has implemented. First is the transaction of updating or creating result assets according to query type. It's in this transaction that the chain code query the external API. The second one is the transaction that the GoBio chain code calls to get the query result. It's a transaction invoked from inside the GoBio chain code, and it only returns the result asset that has been stored on the ledger. For this case, for this use case, it's necessary to implement a custom transaction to update the result of a query to the Seon API for several emails from a person because the worst score asset transaction needs it. So the update email score transaction was created to do this work. Now we're going to demonstrate this use case running. We need to open network with 3 organizations, one being the Oracle. And for this, 3 virtual machine instances were created on Google Cloud Provider, as you can see here. And we're going to deploy this network with a blockchain network orchestration platform developed by GoLedger, called GoFabric. And to create this network, let's click here. And then we define the organizations, org1 and org2, and also the Oracle. And we put the IP address of the machines created for each one of them in this field. The next step is to create the channel. In this case, there will be only one main channel. And then define which chain code will be installed in each peer of the organization, and also the endorsement policy for each one, following what I presented earlier. After filling all necessary fields, we deploy the network, and with the network up, we can test our solution. First, let's create a register of mine in each organization. In org1, my register will have this email. It's my work email. But in org2, my register will have a temporary email. And before calling the worst score asset transaction, first we have to create the query type asset with the Seon email API URL. This one. Now we can get the asset from the person most likely to be fraudulent. Let's see which register of mine has the worst score. I modified the chain-code API to call the Oracle update before calling this transaction. So you have to set it through the argument corresponding to update the Oracle and say which update transaction it has to call. And as I showed before, this specific transaction was created to update all email scores necessary. So we are going to call it. And then we get as result the asset in which I registered a temporary email, which has a score much higher than age. We just saw how to implement an Oracle on a Hyperledger Fabric network. I hope you like it, and thanks for watching.